Hi, this is Lucas. I'm doing a creative contribution again. This one is about vectors, and I've chosen to do problem number 65 out of the different options that we had. So I wrote out the problem. It goes, a man starts walking home and walks 3 miles at 20 degrees north of west, then 5 miles at 10 degrees west of south, then 4 miles at 15 degrees north of east. If he walked straight home, how far would he have had to walk and in what direction? Since he didn't walk in a triangle, I couldn't use the law of sines or cosines. So instead, I just opted to use just vectors. And the first thing I did was basically translate the information into real angles. So as you can see, I kind of color coordinated, and you can see, for example, the 3 miles at 20 degrees. So, or 3 miles at 20 degrees north of west. So we know that, kind of looking in this left corner here, west is 180 degrees. So 20 degrees north would be minus 20 degrees, which gives us 160 degrees as a general direction. And then 4 miles at 15 degrees north of east. East is 0 degrees. North of east is plus 15, so that gave us 15 degrees as a general direction. And then 5 miles at 10 degrees west of south. South is 270 degrees, and then 10 degrees west of that would be minus 10 degrees, which gives us a general direction of 260 degrees. So that was the first thing I did, was, get the general direction. And then I did a rough sketch on a graph to see what the general direction would be. So this isn't perfectly to scale, but I did a rough sketch. So we did 160 degrees here, and then we have 260 degrees here, and then 15 degrees here with the magnitude. So this is 3 miles. This is 5 miles, and then 4 miles. So the goal here is to find, this point, this point to this point. And we can do that by basically adding all three vectors. So it'd be, vector A plus B plus C. And that would give us our new vector. So I relayed the same information here. And then I kind of just wrote out what the goal is, which is find the magnitude and direction of the sum of A plus B plus C. So we have A, B, and C. So the math gets pretty nitty and gritty here, because a lot of these angles are actually all three of these vectors. None of them are directions that you can find on the unit circle. I made sure that my calculator was in degree mode, and I just plugged everything in. So, for anything that's in these brackets, I have cosine on the left, and then I have sine on the right. And just as an example, for this guy right here, I just plugged in 3 times cosine of 160, and that gave me this number, and then I did 3 sine 160, which is the same thing as saying 3 times sine of 160. And when I typed that in, it gave me this answer. Or no, excuse me. Those are the answers without the 3's in front of them, and then timesing them, as you see, the 3's still there. These are the final answers. So I did that for every single problem. So for vector B, I did 5 times the cosine of 260 to find this number, and then 5 times sine of 260 to find this number. And then for vector C, the same thing. I got radicals. 4 times the cosine of 15 is equal to radical, or square root of 6 plus square root of 2. And then the sine is the same thing with a minus sign. So with all of this information, once I had all, I had the x and y values for all 3 vectors, I essentially added all 3. So I did, excuse me there, so I did cosine of A, cosine of vector B, cosine of vector C. I added all of them, and then it gave me a value, right? Let's just call it, we'll call it cosine sum. And then I did the same for sine. Call that sine sum. And this value is down here. So that's my sine. Here's my cosine. And to find the magnitude of this new vector that I'm trying to find, I just found the absolute value. So I did that by squaring each of these values, adding them. That gave me 8.16 here, and then getting the square root, which gave me 2.86, which rounded gave me 2.9 miles, and it's in miles because all of the original information we got was all in miles. And then to find the angle, I just plugged our values up here, our cosine and sine sums, and I found the tangent, and I just plugged it into my calculator, finding the inverse tangent. So as you can see, here, let's find bright color. These two numbers here, I plugged into here, and it gave me 86 degrees. And it was actually negative. But regardless of what you get when it comes out, you want to make sure that it's going to be in the right quadrant. And from my rough sketch, I knew it was going to be in quadrant 4, right? Quadrant 4. So down here at the bottom, I wrote out quadrant 4. So I did 360 degrees minus our answer, which gave us 273.5. degrees. And that's basically it. So final answer, he walked 2.9 miles. The 2.9 I got from the magnitude right here in the direction of 3.5 degrees east of south. Now just using the same language that was in the asked question. So 3.5 degrees east of south is the same as 273.5 degrees as a general direction. So what we know is, wait one moment. So what we know is this hidden angle that we've been trying to find is 2.9 miles at 273.5 degrees. Thanks for watching.